Yeah, I'm just going to get rid of this. Okay, so this is our agenda for this evening. I'm going to say thank you to a couple of different folks who are our sponsors and they make this happen. So the first one is esynergy. We're in their offices today. I am going to leave Alan, our first speaker, to do a proper introduction to esynergy. For the other companies, Circle CI, Sysdig, and Styra, I'm just going to read out a couple of lines from them. Since they cannot join us this evening, although please raise your hand if you're from one of these three companies. I want to do a quick shout out. Okay, so Circle CI, the world's best software teams use Circle CI to deliver quality code with confidence. As the largest CI/CD platform, Circle CI empowers engineers to seamlessly take ideas to execution at scale. Sysdig is driving the standard for cloud and container security. With Sysdig, you can prioritize software vulnerabilities, detect and respond to threats, and manage cloud configurations, permissions, and compliance. Your teams get a single view of risk from source to run with no blind spots, no noise, and no black boxes. And then from Styra, who's a new sponsor, Styra is a cloud-native authorization from the creators of Open Policy Agent. Define, enforce, and manage fine-grained policy as code across infrastructure and applications. And it allows developers to release code quickly and safely by providing automated guardrails. So they align infrastructure resources with security, compliance, and operational needs. Okay, thank you to all of our sponsors for this evening. I see some folks at the back who have showed up just in time. So Amanda, do you want to come and say something about state of OpenCon?
Good evening, everybody. I and my little band of helpers at the back of the room are organisers of the UK's first Open Technology Conference. I'm Amanda Brock, I'm the CEO of Open UK, and we're an organisation about open source software, open hardware, open data. We have a conference on the 7th of February in the Elizabeth II Conference Centre, which is just on Parliament Square. It will be for around 1,000 people. We have 5 floors of a building, as well as 7 tracks. One is platform engineering, one is security, that I think will be very, very, very relevant to this crowd. We will also have open data, open hardware. We've got an unconference, Sustain OS, if any of you know them, we're running a sub-conference within it. And we'll have a whole set of stuff around developer and delegate experience. So there's going to be 3 floors where there'll be lots and lots of interactive stuff, headsets, 3D printing, all sorts of different stuff going on. 2-day conference with an evening event as well. Tickets are 100 quid, but for about 199 actually. I'm reducing the price as I speak, but 199 for the 2 days, heavily subsidised. For this evening, we have 5 tickets to give away to this meetup. So if anybody wants to have a ticket tonight, can you let Cheryl know? And she will somehow, if there's more than 5 of you, pick the 5. So I hope that we'll see you. The URL's on there if anybody wants to come along, and please do share. We're also looking for some volunteers. We've got a large volunteer community running the event. And for anybody who buys a 2-day, or anybody who wants to come, you'll get a 2-day ticket for 1 day's work. So it's, work 1 day, have a 2nd day at the conference. So I hope we'll see some of you there. Thank you.
Thank you, Amanda. Yeah, I definitely hope you take advantage of this. Just get in touch with me through Meetup, like send me a message, or you can find me on Twitter and just let me know if you want to claim one of these 5 free tickets. A little announcement. So this is the last time that we're going to be in this building. We are moving homes, moving to a new venue from February. I want to say an enormous thank you to all of the esynergy team, particularly Javier, Sean, Patrick, and Chili, who Chili is asleep on the sofa over there. It's a dog, but she's clearly the most important one. But Javier, and Sean, and Patrick have been absolutely amazing partners for us, and I'm very sad to be leaving, but they're moving to a new office, a different office, bigger office, so they can no longer host us. From February, we're going to be in the Just Eat headquarters instead in Holborn. So please make a note, and I'm looking forward to seeing you all there. Okay, right, now time to hear a little bit about you. So please grab your phone. We're going to do a little bit of live polling. Go to this link, boycheryl.com/p. And I'm going to ask a couple of questions about you and a couple of questions about how you use cloud native. So it's going to send you to this poll everywhere service. You don't have to put in a name. You don't have to download anything. You can just skip and go straight to the poll questions. Okay, so first question is this your first time at Cloud Native London? Yes. So you can see some people already figured out. Yeah, they're submitting yeses and nos. Looks like, ooh, we're pretty 50-50. Some yeses pulling ahead. And hopefully there are people on YouTube and Twitch who are also live polling with us. So that's awesome. If this is your first time, then welcome. I'm very, very glad to have you here. Also very glad to have people coming back, of course. So next question, what is your job title? Just pick whatever is closest to what you do. Architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. Okay, it looks like the results are coming thick and fast. So architects are 30%, same, others seems to be putting ahead as well. Okay, super interesting. I feel like we have more architects here than usual. And no security engineers for this evening. Nice.
No,
okay.
I'm giving up.
The next question comes from Eric, our second speaker. Will or does your organization have observability across their cloud landscape? And Eric, I might ask you to sort of comment on the results as they come in and whether they align with what you're expecting. So the options here were we're trying very hard to have it. We struggle to cover our cloud landscape. We don't have a cloud landscape yet. Or what is cloud native observability? So Eric, where are you? So
That's exactly what I expected.
This is exactly what you expected? Okay, nice. So 50% of people trying very hard.
We're all trying.
Yeah, we're all trying. But there's a number of people who haven't heard of cloud native observability as well.
Those are the architects.
Those are the architects. Hopefully there's some of we'll answer some of that in your talk. Amazing. Okay, and then our next question comes from Carlos. So do you use ARM processors? And your options are in my phone and tablet, in my development laptop or desktop, in my VM in on-prem, my VM in cloud, or in my bare metal servers. Raspberry Pi is a bare metal server. I don't make the rules. Carlos, are you there?
I am. Can you hear me?
Hey, are you there? Can you hear us?
Yep.
I don't think we can hear you. Oh, we can see you.
Can you hear me?
Just wondering if can you say something to make sure we can hear you?
This should be working.
Okay. We're not hearing you yet. Maybe that's something for Sean to take a look at. Okay, anyway, let's see what the answers came out. So 24% saying in my phone and tablet, 19% saying in my development laptop or desktop. That's pretty high. That was higher than what I expected.
It's the new Mac.
And 23% saying in bare metal servers as well. So yeah, actually pretty interesting numbers here. It's much higher than I expected. Okay, awesome. So thank you very much for taking part in the live polling. That concludes this section. I need a selfie for the purposes of social media. So just hold tight. Thank you. Okay, smile, wave. Cool. Thank you. Thank you very much. And then lastly, if you want to come and speak or sponsor as well, please go to cloudnativelun.com. I think our next speaking slots are in November. So if you feel like coming and talking about what you're doing, then just plan ahead. You don't have to give the talk title now, but just plan ahead for the end of the year. You can also sponsor and help us out with beer and pizza, or you can share any other events, just like the Safe Open Pond that you want to. Oh, and that is it for me. So I'm going to stop my share and I'm going to hand over to Alan. And Alan can share and take over.
Yeah, I can, yeah, just give me a minute here. Can you hear me all right? Are you able to hear me? Hello?
We're not hearing. Is Sean still around? Can you check if it seems like there's an AV issue and currently not.
Speak is off. Yeah. You there? The speak is off.
Hello?
Maybe I can let's do this then. Not working. I'm not hearing this.
Can you hear me?
Yes, it's mute.
The volume was off. I've lost.
Make it to headphones.
Yeah.
Yes. You can do
Hello,
more
hello.
Okay.
Apologies, it'll take a minute.
Tuesday.
Looks like it's kind of on the phone now. Okay, take a breather. Aaron, can you hear me?
Hello? I can hear you, yeah. Can you hear me?
Yes, we can hear you now. Amazing.
You can hear me now.
Thank you.
Oh, fantastic. All right, solved. Great.
Round of applause, please. Welcome. Welcome, Alan.
Thank you. Thank you very much. Sorry I couldn't be there this evening. Yeah, I will endeavor to come for another event. So today's talk, I'll just quickly recap esynergy. So I'm a lead associate at esynergy. My area of expertise is cloud and platforms solutions. esynergy is a tech consultancy. We specialize in cloud and platforms and custom engineering, and the focus really is all about value. They have a very wide community, really useful to join. It's how I kind of came in contact with them. I mean, I've had a long career, I suppose, with esynergy. I started with them almost 10 years ago, and then doing other things, and they got in touch, and it's been a happy relationship ever since. It's a really good network. We talk about cloud, we talk about platforms, we talk about data. There's some really interesting things to get involved in there. So that's esynergy. That's the sales marketing bit done. The talk I'm going to do here is something very close to me. I've done a number of migrations, and let me flip to that next slide. So the older part is because I'm actually in Spain. Lived in the UK for a number of years, and then came over to here, and I'm working remotely and back and forth. But my first project on cloud was in 2011 for O2. It was not a migration, but just in a greenfield project. There were hardly anywhere near the number of services you have today. We didn't even have VPCs then. It was classic ELBs were actually just ELBs. So it was a few years ago, and things have changed a lot since then. I've been involved in a number of large scale cloud migrations, mainly in enterprise. So my industry is generally in the financial services, so it's highly regulated industry. The organizations I've been working with tend to be enterprise, so Fortune 500 companies. telcos, banks, insurance companies, and a government here and there project too. I've worked on most of the CSPs. I'm talking all mainly about AWS because that's kind of where I started, but I have used Azure, I have used Google Cloud as well. And I have had done that in a number of capacities, right? So I'm an engineer from is my background, and I moved into DevOps and automation, and then sort of the encompassing cloud came along, so started working heavily in that, and I've put down my hat as a kind of architect now, lead solution architect, or delivery lead or lead associate, depending on the context. But I'm very familiar with cloud, and I've used it a lot, and I've seen it change and grow over the years. And what I want to do is relay a story a bit about what's actually happened, right? So let's take a little step back. And I mean, I think we've all had all these different transformations. I mean, I've been involved in DevOps transformations, digital transformations, cloud transformations. I mean, they use the name a lot, but I think it's kind of an interesting type of change. A lot of organizations really struggle with this type of change because it's a pervasive change. It's a very significant change. And I'll go into that in terms of cloud, but in terms of digital revolution, what are we looking at? Where does cloud fit in this sort of ongoing digital revolution that we are going through, right? This has started in the latter half of the 20th century. We've had, PCs become affordable, become, mass market, the invention of the internet, mobile communication. All of these are major digital transformations, and that had massive changes in the industries, in the social aspect of it, how we interact, how we communicate, all of these things, right? And I think cloud really is on this last point. It's the proliferation of digital transformations across all business sectors and markets, right? It's really this changing. You might hear omni-channel thrown around, this new ways of communicating to business, new ways of interacting with business. Cloud is really a big part of that, right? It's now a new way of managing your infrastructure, hosting your infrastructure, and now becoming more of a platform based. And we're going to talk about cloud native as we go along here as well. But the transformation is significant, and I want to put that in terms of what is it in terms of size, right? And I think a good way to look at that is terms of revenue, like how big is this market, right? And how fast is it growing, right? So you can see here in 2019, this market size was 304 billion, and now in 2022 is 555 billion. I'm guessing that's some sort of rounding. And then by 2025, we're looking close to $1 trillion market, right? And you can see this across organizations, right? It's holistic. It's now not even, are you going to the cloud, but what is your cloud strategy, right? That is incumbent as part of a lot of organizations. It's part and parcel of their digital strategy, right? So I think what's interesting about it is the significance of the change, the amount of change that's also going on here as well, right? And that I also want to discuss. So here we have this. Actually, this gives you another view. This gives you a view on the types of digital revolutions that have been going on and where cloud kind of fits in there. It's a sizable and significant change, right? And I think I keep coming back to change, and I think what's important to understand is this as well, right? So, we have all kinds of changes going on, constant changes. Businesses are going through changes. A business that surviving and thriving is changing all the time, right? But this is a slightly different change, right? This is a transformative change, right? This is doing things significantly differently, reshaping things the way you thought today, the way you thought about doing things is now different. So think about the obvious things in terms of cloud. You know, there was a whole procurement process for purchasing and then racking and mounting your servers, which is gone. Now it's you know, it's through a credit card bill and a set of APIs, right? So this is significantly changed how the business can react and how fast it can move as well, right? So we'll keep going along here. Now, transformative change is really, how significant is it? It's sort of saying, you know, you're coming to a business going, okay, you're going to go to the cloud, we're going to close these data centers. What's the effect on our business? Obviously now we're not going to have this data center. Well, it's probably likely to affect pretty much all of your existing processes and procedures in IT, yeah, in some way. You may not actually change it, but you may need to review it or reword it or whatever it is. But the significance is massive. And a lot of organizations, I understand, you know, from experience, underestimate that amount of change, right? They also start to think of things in a, you know, in the old way, right? So think about a data center. Data center was about maintaining the walls, the fortress around your data center, making sure intruders weren't coming in, and making sure data wasn't going out. Now that's completely changed. Your data is now in a shared service, right? It's in a network that's untrusted, and you don't manage your own. So you need to take a very different look at things, right? And this is where you get things like zero trust, right? So we're moving away from this, what I mentioned there, the fortress, the walled data center, into having to handle security, across the board, right? Ensuring that standards are all met across, and ensuring that you've got approaches so that, you know, as your users are connecting from remotely anywhere, you're able to understand, you know, what's the attack surface there, right? Like, because that's completely changed, right? I think the other side of this as well is, you know, you find is with that is that change so significant and is risky, right? It's risky for a business, and that becomes quite a challenge, right? They often want to go, well, we want to mitigate these risks, so we're gonna maintain the constructs that we have. We're gonna have all these perimeter devices, and spend thousands, if not hundreds of thousands, on licensing for firewalls, not going sort of, you know, using the power of the cloud. And that's really been one of the major challenges that you find with an organization. It's willing to go to the change, but you know, security and compliance, they need to maintain certain rules and mitigate certain risks. And that change process can be fairly long. Now, I think we've all, you know, as organizations have matured and organizations have gone through this, and the cloud has matured, this is becoming easier and becoming more of the norm. But that challenge has been something that I've seen continuously throughout organizations. We'll continue on. I don't actually see how we're doing for time. Okay, we're doing all right for time. So one of the other things as well was, you know, we talk about cloud strategy, right? And I think this is something that's close to heart for me, right? Because there was a lot of misconceptions around cloud initially. It was you know, well, we don't need to manage this anymore. We can save money. We can put it onto the cloud. Well, but the cost of running workloads on the cloud on a kind of over a period of, you know, years is going to be more than you can, you know, run it in a data center. Maybe there's a nice option of not having to put that upfront cost of purchasing the hardware. But really, over the lifetime, you're looking at probably a larger spend. So you need to think about cloud a little bit differently, right? You don't want to do a like for like. It's just, that is not a cost optimal approach to the cloud. You need to have look at the value of the cloud, right? The proposition is not a cost savings, right? It's really about, I mean, performance elasticity. It's the reliability side. It's the security. It's the ingenuity that's coming out of the cloud, right? Those are the things you want to get to, right? It's the fact that now, rather than procuring hardware and having to go through this lengthy process of setting up hardware, you can spin it up quickly and you can get to market faster, right? And this is the benefit, right? And that's an interesting cost benefit of analysis of the cloud. And I think as we are maturing, we're seeing organizations now really diving into what people are calling or coining FinOps, right? Because we've all gone to the cloud and said, oh, fantastic, we can spin up something really quickly, do everything on this. And it's been 2 or 3 years and we've realized, oh, right, we didn't really need all those things. We kind of capacity planned based on what we had in our data center, which had a hard limit. So we always had to size things according to the maximum. Where, you know, cloud, you don't have to do that, right? So you're seeing that maturity coming along as well, where you have, now we're going, well, how can we make this more lean? And I think that's where you get, you know, cloud native is crucial in that, right? Because it's talking about, you know, following those paradigms, you know. One of the things that I just wanted to, as a side note, to mention here, this map here, this came out of a center of excellence or center of practice around cloud out of Equal Experts, out of esynergy. And I think one of the things that's really useful for organizations right now, obviously our interests are a little bit different than an organization hosting their workloads on the cloud, but I found that like a COP is crucial for disseminating information, for understanding how to approach the cloud, for doing exercises around, you know, cost optimization or FinOps, right? So putting controls in place so you're not overspending or you're getting anomalies, that kind of stuff. So I think one of the things that I found really helpful when, you know, as a migration to the cloud is to build those center of excellence or center of practice around cloud, so that you start to get those conversations around improving, right? You don't want to get to be in the cloud and go, we've done it, now we're gonna leave it now. No, it's a continuous improvement, a continuous change. And I think one of the things organizations I've found is that they've migrated to the cloud, and it takes a little while for them to obviously absorb these changes. And it's the second iteration where you start to look at, oh, well, how can we make this, you know, less of a burden on our infrastructure team or our cloud operations teams or our DevOps within our team, however your organization is structured. Yeah, I think that's another really interesting thing that's kind of I'm starting to see pervasive amongst customers who've migrated, you know, 4 or 5 years ago. Continue on. So at esynergy, out of that center of excellence, we've built a phased approach to cloud migrations, a very detailed approach. This is just sort of a high level view of it, but it tends to fall into 3 phases, right? Now, there may be one tacked on the end if you're exiting a data center and need to, dismantle the hardware and clean out the data center. But loosely for this is around what you're going to do in terms of migrating to the cloud, right? So the first piece, and before discovery, I would recommend always for every organization, and it's usually a bit of a red alarm for me if I don't see that, is a business case. Why are you going to the cloud, right? Because a lot of organizations, they know that other organizations, it's a strategy. It's part of our strategy, but you really need to be clear about the objectives there, because initially going to the cloud certainly will raise your operational costs. And it's once you've decommed and sort of got, stabilized your estate, that then you can sort of optimize your operational costs and your TCO in the cloud. But really that's a super important thing, because discovery is really about, evaluating that business case and proving it, right? And preparing what's the effort and what's the cost to do things. The next mobilize is readying the cloud, preparing all the supporting the platforms, like it could be a delivery platform, it could be your monitoring, alerting, your change process, preparing all those for your first Lighthouse application, which you'll deliver as part of the migration. The Lighthouse app is the way of proving out your Rails, right? You've built now, you built a platform in the cloud. You're now readying for migration, and you're migrating your first app and running it. And then after that, then it's just about scaling, right? Easier said than done, but certainly an approach which I found quite successful in experience. One of the things to note is, and if there's anyone interested out there, we have done this a few times now at esynergy, is a lot of the large CSPs, the three major ones, they offer investments, right? So at AWS, it's called MAP. And that's where you can get, depending on the size, it needs to usually be an enterprise grade migration, or at least a kind of $1 million spend in the cloud. But you can get credits or cash even to basically facilitate these phases. Yeah. Now this is an interesting one. This is one I really like now, because initially it was all about using cloud services. There's now a plethora of cloud services, from the CSPs, but now that lots of other organizations offer SaaS and PaaS. An organization is becoming multi-cloud, whether it acknowledges it or not, right? I may not be hosting on the two of the major CSPs, but half of my other services are either PaaS or SaaS, and they're hosted in the cloud. So you're becoming a multi-cloud organization just by generally consuming the often tools that support big software development teams, right? What I like, the one thing I like about cloud native is all the principles. The part I'm not so sure about is the actual naming of it, because I don't think cloud native is actually meaning that you're always running your workloads on the cloud, right? I think it's about an approach to managing workloads, right? To software development, right? And I think these kind of encompass for me the four major principles around it, right? Building and running it, enabling teams to do things, not building monoliths, building manageable systems, resilient systems from start, right? And then moving fast and adopting agile continuously, and looking to being increasingly flexible to the business, because that's the core reason you're doing these things, right? So I think this is something that's really interesting that's coming out of the cloud, and I think it's evolving, right, as a kind of pervasive way of engineering, which I'm happily being a part of, and glad to be part of this community, and to do this talk. So my final statement is really, the point I'm trying to get across here is that cloud is a pervasive change. If we looked back, there's been a number of pervasive changes, and there's going to be more pervasive changes. And I think out of the things that we can learn from cloud is how we approach a pervasive change. Yeah, how we do this transformative changes. Taking the learnings from that. And I think lots of things have come out of that. And I think we'll see that there'll be another thing coming along, and we'll need to adapt our principles around cloud native, or maybe we'll adapt our principles around agile. But it's important that we are constantly thinking about that. Anyways, that's the end of the talk. If I can, Cheryl, should we go to questions, or how do we want to do that? Oh, thank you.
Spontaneous round of applause, yes. Yeah, let's go to some questions. I'm going to take over sharing screen again for a moment and put up.
Yeah, I'll stop. Sorry. Yeah, you got it. Okay. Mhm.
In case anyone wants to still use the poll everywhere, you can add questions via that, or you can just shout if there's anyone in the room who has a question for Alan. Any questions? Oh, one at the back. I'll come round with the microphone.
So it was really interesting to see a lot of your perspective on the growth of the industry and where that growth is coming from in comparison to areas like fintech and social media. What trends do you think are helping that grow? We see a lot of people talk about kind of serverless adoption, scale to zero being a big cost saving mechanism, but ultimately ending up with a more expensive cloud industry. I think it'd be a good subject for you to touch on.
So yeah, I think portability is important. I think serverless is a very good direction to be going towards. I think certainly from using cloud when it was, it was mainly EC2 and load balancers and configuring this, managing networks. This was, an overhead that really, once you started to see that you continuously had to do it, really, it could have been, encompassing as part of the platform and easier to consume. And I think serverless is driving that. What I see, I think, is coming is much more, less. It will become less that we all host in one cloud provider, and that we are moving towards more PaaS and SaaS and consuming all kinds of services, not necessarily hosted in one CSP. So I'm hoping that the market will diversify more, right? That we won't have, I think there will always be a need to manage lots and lots of workloads, and AWS and Azure and Google Cloud will do that continuously. But I think, if businesses are changing, opportunities are for smaller companies, to basically get to market. Think like, no code solutions and stuff like that. I think this is where I would see some growth and trend going, right? Because that to me makes sense, right? It's because cloud has been pervasive in getting to market quickly, right? It was really pervasive in that. So I think that will hopefully grow, and we won't just all use Amazon. Even though I quite like it, I'm not knocking it. What's my favorite CSP? So I have two views on that. I have the developer view, which is Google Cloud, GCP. That's just very developer centric. There's just so many things that make sense that are easier to do there. And then it's AWS if I'm going to a customer who's going, you need to do all these different things, and AWS does everything, right? You never have a question of that, right? Unless we're trying to migrate a mainframe, then, it does most of that. And maybe you can even do the virtualized mainframe stuff. I have never got into that. So do you consider services like RDS, EC2, and others as cloud native? Good question. EC2, no, I tend not to. RDS, yes, I think it's an interesting thing. I would think, when I think cloud native services and serverless, what I've used more and more now, tends to be some sort of storage. It could be a distributed storage, or it could be RDS, depending on the requirements. But if I'm using EC2, I don't believe I'm doing it the right way. Now, I say that with one caveat. If I'm deploying Kubernetes, it's a little bit difficult not to use EC2 in AWS. But really, if I think like you're going to do some sort of API services or a static website, I wouldn't be going anywhere near Kubernetes. Do you need a backup in the cloud and cloud? Yeah, definitely. For me, that's like it's like driving a car without a seatbelt. It's just ingrained in me now, right? yeah, I mean, backup is crucial unless your data just doesn't matter. For me, that's always the question. If I don't care about this data, then fine, why am I backing it up? But if it's valuable, then yes, definitely, it's important to back up data. What is the drawback of using cloud? There's a few drawbacks of using cloud, I suppose. One is the cost and the unknown costs, right? So there's a lot of hidden costs in cloud that you need to be careful of. And those are always not fun conversations, like, suddenly I mean, I worked for an organization where we were looking at optimizing data transfer costs because they were $100,000 a month. I mean, and you just think that seems like a total waste of money. And then you get the odd thing where, no one cleans up EBS and you end up with this $5,000 bill a month for EBS, but now we need to go through all of it and understand what we need to keep. I hate that kind of stuff. That's probably a problem that you'd have on-prem, just slightly different, but yeah, at least you don't get this crazy ballooning of costs as a result of it. Or at least you see it coming a little bit easier. What is your opinion on web ASM? I don't have an opinion on that. I'm afraid. In your view, is there a post-cloud world, the next big thing? Yeah, God, if I knew that would be great. Yeah, I think we're going to have cloud for a long time, right? I think there are organizations that I've heard that, where I remember we were having these conversations initially, and they're talking about, no, we're going to do private cloud on-prem and all that kind of stuff, and you're thinking this is not going to work, but in some respects it does. In some respects, for certain types of workloads, it's maybe a more cost-effective way of doing things. I've only ever really seen that in a very large scale organization which has specific requirements. And maybe if they just listened to Google and said, well, just why don't you containerize everything, and then that problem goes away. Yeah, it's kind of an interesting one, the post world. I think our cloud is just going to evolve. I think for the next 5 to 10 years, cloud is going to evolve and going to change. And this kind of sticking things into AWS only is going to change pervasively, right? Because we're going to have more PaaS, more SaaS, and it's going to make more sense to use those than manage workloads, just as we're moving away from EC2 and using serverless, right? We don't want the burden. We're paying money for something that's, depending on what you're doing, can be significantly more expensive than hosting it yourself. But you get all those values. You get quick to market. You can destroy it. You can copy it, build it, all that kind of stuff, right? Which is important. I think that just needs to become easier, and whoever starts making that easier, businesses will flock to that.
I think we've got time for one more question.
Lots of great. Okay. Wow. Okay. So hidden costs are what most hyperscalers are guilty of. How do you think folks should look outside the big three? I think there's more and more opportunities out there. I mean, I've used a number of cloud vendors, right? It just depends on your need. Like I remember I had a project where I wanted a basically really low cost. It didn't really matter that the software was running all the time, but it was churning through data, right? So we wanted to keep the data in one place, and we wanted, cheap compute. There's options for that, cheaper than AWS. Yeah, so there's all kinds of opportunities out there, but you need to look at it, and it needs to be on, a specific use case. Anyways, I think I've got to stop now.
Thank you. Yeah.
No, hand over to Cheryl.
Thank you so much for all the questions as well. It was great. Another round of applause.
Yeah, that was great. Thank you.
All right, next up, Eric, would you like to take the stage?
I'm going to start taking this.
Yeah, do you want to join and you can screen share? Huh? Okay. Go for it. questions. Over to you, Eric. Round of applause, please.
Okay. Evening, I hope you're awake. Let's go back to that question about who you guys are. Raise your hands if you're the architects. Okay, the SREs. Everybody look at these guys. Keep your hands up. These are the most important ones.
Well.
We're the developers. Okay, keep your hands up, developers. Do you consider yourself DevOps? If not, take it down. So who's doing DevOps? And platform engineers? You said you were a developer. Okay, just getting a little bit of a feel of the room, right? That's kind of important here. So what we're going to talk about is 3 pitfalls you should avoid with cloud native data. It started out as a talk around cloud data, believe it or not, back in 2018, I think it was. And we kind of got into a discussion, a friend of mine who worked at Red Hat, and I was working at Red Hat at the time, and he was a solution architect who had backfilled me. And I was going around the world, and he was still handling the customers and moving into the cloud, OpenShift. Another question for you, is anybody using OpenShift?
Yeah.
So you do know what we're talking, like a container platform, not vanilla Kubernetes. And it was basically turning into a bitch session, right? The customers are stupid. They're doing this, they're doing that, they do this. You keep seeing the same problems all the time. I'm sure you guys have the same thing going on. And we came up with 3 little things we could talk about here. And it's evolved over the years because we've grown, right? Since 2018, things have gotten a whole lot different. But what's scary is the problems really haven't changed. They've just been exacerbated, right? And we're going to cover these things. We're going to talk about cloud and data, what that is and what the costs are. Aaron already mentioned a little bit of this. He was very careful to gloss over it. I heard you guys giggling when we say, yeah, there's hidden costs, right? And then we're going to talk about observability as data. There's something in the way there. And then why FinOps? We believe FinOps is going to be the most crucial operations, right? I mentioned that we gave this talk way back then. I want to show you proof. That's how long this has been around. This thing it really took off like a bottle rocket. The first time we did it, we had about 100 people in the room, and 3 different guys came up and asked me to come through Central USA and stop at there and talk to their CIOs about this. They were relatively shocked, which is kind of stunning to me. And I'll be curious here at the end. I want to come back around and see if you guys are shocked at what I cover at all, or if you just think this is normal and very, very, yeah, what you expect to happen. So we talked about how you go into the cloud. We talked about cloud native. Cloud native for me is the people that are on, Kubernetes containers. We're talking about a platform. You're describing the state you want on the platform, and then you let it go, and you hope it happens, right? Which is a little bit of the complexity that starts coming out, right? And it was supposed to solve everything, wasn't it? It was supposed to make life so much easier. How crappy was life when we just had a server? And we were talking about it before this thing, right? Back in the day when I was working at the bank, we had a Windows machine. I was logging through to another Windows machine, which was basically a VM. And we would go to build our Java apps, and we'd have to take a break, go get coffee and talk about all our coding problems. Because it would take 40 minutes to build your code, right? Waterfall methods and stuff like that. And it was, agile was the cutting edge. Cloud to me feels like this. It really does. It kind of didn't really solve the problem, right? People are making a shit ton of money on it. That's for dang sure. And everybody thinks they got to be there. How many people here are working in an organization that's 100% in the cloud? That's better than it was years ago. But it's not even half. It's not even close, right? Not even close. I love that one thing about, he made some comment about, hey, let's put everything in a container. Have you tried that? That's just not how the world works, right? So one of the questions, we sprinkled some questions in here, and these are more about setting the mindset, right? Do you understand what this means to a company? So when you're using the cloud, when you're using a data center, you don't really care. It's free to send data all over the place, right? You go into the cloud, this costs money. Think of water through a pipe, right? Are you using a fire hose? Are you using a garden hose? You don't have that control all the time. Think of the pandemic. Think of I don't know what would be the right one here in the UK. But in the US, you have something called DoorDash, delivering food, maybe Uber Eats.
Yeah,
It exploded the usage. It was in the cloud. What do you think happened when they started hitting all those services? We'll spin up more services. Let's spin up some more services. If you didn't architect thinking about this, your data might be coming in and out of the cloud. Now it's going through the pipe. It is not a fire hose. This is a dam that broke, right? And the costs just explode. And how many people have something in place to stop it? Anybody here have anything in place? Did you learn your lesson the hard way?
Not yet.
I mean, to put something in place.
Yeah, no, to put something in place before learning the lessons.
Okay, but I mean, somebody learned the lessons to teach you to
Yes,
do that, right? I mean, that's really rare. And how many people here do their little development stuff and spin up something on their credit card and get surprised and they can turn it off? They had that happen. Yeah, everybody's had that happen, right? It's just what happens. We'll get back to that. There's all kinds of fun around this. To give a really solid example of this, not everybody needs to go into the cloud. There's a lot of people that avoid it like the plague. Here's a really great example. The press, if you translate this, is the press group. I'm from Holland. This is a Dutch-Belgian company. During the attacks in Paris, when they printed that cartoon that pissed off a lot of people, and there were some terrorists running around shooting everybody, and the whole city was shut down. So what is everybody doing at home? They're whipping out their phones and they're getting onto the French-speaking websites, trying to find out what the hell's going on in their neighborhood, right? Crashed all the websites. But right across the border in a place called Wallonia, you can cut over there and there's a couple of websites that are being run by this press group, which is in Belgium and in the Netherlands. And he got asked this question. He says, why aren't you guys in the cloud? And he goes, well, I'll tell you why. We had a quote once to look at this. And he said, when this happened, we had like an 800% surge on traffic. He said if we would have been in the cloud, that scale up that happened would have bankrupted, 2 websites would have bankrupted the whole group, 2 countries. Budget's gone, everybody can go home. These guys never want to go in the cloud ever. They buy data centers, they don't buy, you know what I mean? They don't buy cloud space. They have no interest whatsoever in going up there. The business model does not work for this use case. And there's more out there like that. To give you a little bit of proof, these are not my slides, these are his. He was the CIO of this. And it's not so much about the numbers, but I think the percentages are pretty clear. I just doubled your traffic on that one site. Probably if you'd been a data center, it would have just fallen over, right? What you don't really see here is what about the monitoring? What about the observability stuff you have on there? That's a factor on top of this, which we'll get to in a minute. So does everybody know the term Ollie? Everybody or just you 3? Everybody know what K8S is?
Yeah.
It's the same idea. Observability really sucks as a hashtag. So everybody turns it into Ollie. The 11 letters in between get removed. All right, so we're on the same page. Works better on slides too. And SREs, does this kind of catch your mood? That's what I mean. These guys are heroes. You don't understand what they do. The 3 guys that raised their hand for that, how many SRE jobs have you had? There's 3 of you, so you first. How many?
Second one.
You're in your second one? You?
Fourth.
4th or 5th? You're still doing it?
I wander around, call myself different things occasionally.
Okay. Where's the 3rd one? There was a 3rd guy here. No? Oh, okay. Sorry, I thought you were the SRE. I just hired a developer advocate, talked her out of her 7th SRE job. She burned out 6 times and says she's a retired SRE at 28. It's funny, but I mean, try being an SRE. You guys have a beeper or pager with you right now? Yeah, see, they might have to run out of the room in a minute. I don't know what you're monitoring, but that stuff's crazy. So this is the question we asked at the beginning, and it's kind of a loaded question because most people don't think about this. Think about all the developers out there. I develop code. I'm having a good old time. Now comes DevOps. Now I have to own the code, right? So we're gonna get to that a little bit later, but you're spending time learning what SREs and DevOps is, or ops is. It needs to be developed, give it to the ops, and that's that, right? In theory. Usually it bounces back because they have no clue what a Java stack traces or whatever, it just explodes in their face and they're like, you come down here, look at it. So you run down to the ops, and go help them out this thing. On top of having any kind of observability, having observability across all your landscape, has anybody achieved that here? I'm waiting for you to raise your hand.
Yeah,
Yeah.
no one can see all and
All
of
of
that.
that, local, everything.
Yeah.
I mean, you got it all? How many tools are you using to do that?
3 at the moment.
Okay. Fun. Yeah, it's a pretty crazy environment. So over the last few years, people have started to look more and more at this, right? And discover there's got to be something we can do to this because of this right here. And I wouldn't care if, so imagine this, I'm going to take the mic away. My production cost of making money, my business, is being superseded by the data costs on just the observability, right? So to monitor the stuff, just a couple of days ago, somebody was mentioning how he wrote this really cool project, checked it into open source. Oh, fantastic. He's writing a tool to monitor his monitoring tool. Python. It's almost a script. I'm like, what are we doing? You know what I mean? What are you doing? We wouldn't care what it costs. I'll guarantee the DoorDash would not have cared what that costs if they're making more money, if they're happier customers, if there's less stressed out SREs, if they're able to remediate stuff faster and fix it when it does happen. Nobody would say a word. Everybody would be super happy with all these clouds, right? Problem is, that's not the case. If you guys are having a beer later, go talk to one of these SREs and you'll see the stuff. Ask for a couple war stories. I bet there's some pretty cool stuff. My CTO is from Uber. He's got some really nasty ones. That's happened there before. Think about this. It's pretty nuts. So let's look at what data means in the cloud. And I kind of didn't want to set up something that couldn't be believed. So I just kind of looked around. And this one has a link in the speaker notes. This whole slide set will be online on my website at schabell.org. Probably is already right now. I usually preload that stuff. In the speaker note, there's a link to this guy's stuff, and it's pretty detailed. And it's just a 4-node single cluster. It's just got a fake app on the front, a fake thing to kind of poke it once in a while. So there's some monitoring of front end stuff. It's got a couple of services and it's got some containers and nodes. Nothing crazy, right? Nothing crazy at all. 30 days of traffic. Look at that. Almost half a terabyte. Half a terabyte. What do you think that costs? Are you paying it, get it in the cloud, out of the cloud? Are you storing it? Are you making backups like Aaron wants to? Usually, this surprises a lot of people. Anybody using OpenShift? Anybody using a marketplace? You just start poking things and spinning it up, right? Yeah, your SREs are already gone, oh, Jesus. Seen developers do this all the time. This is how crap gets into our architecture. You don't understand or don't even care, really. You know, engineer too, right? Developer, I don't care. I'm just building stuff. It's not my problem when there's a label added or something for the metrics. If you want a label, PM, you can have another label, no problem. But that has impact. That creates data. It's exponential sometimes. This is just a baby thing here. This is not even serious. Imagine if you're doing something real. This terrifies me. Next thing is, you look at some research around this, the average time, usually probably because of compliance rules, the retention rates are 13 months. Across all companies, take an average. This is some kind of IDC thing, I believe. Because people don't sit down and think about, oh, what about my test environment? What about my development environment? What about, I'm just spinning stuff up for an hour and a half and then I throw it away. You don't have different policies for that kind of stuff, usually, by default, usually. Because you're saving all of that for 13 months. Ouch. Another really cool example, can't give you the name, I don't work there anymore, so I can't tell you red hat customer stories, but there's a very large airport here in Europe, and it has been involved with going into the cloud and trying to figure that out with microservices, also do analytics around the data and stuff for the airport. I think one of the first tries they did was doing the analytics and then pulling it out. Ooh. So now you architect, you've completely changed how you architect solutions because you're working around these kind of pitfalls, right? It's not how you ideally want to do it, but it's what we have to do, which is also questions you got to start asking yourself if this is really a good idea, for everything we do. So don't despair. It might feel like the water's coming up around you and you're drowning in all this stuff. But the idea is here, we want to get, and if you look at DevOps, the devs are getting sucked into so much stuff and spending so much time doing ops that it's no longer available anymore, right? So I actually did a talk around this, where this slide was in it. And I was looking around the internet. If you look around, you see what you can find. I just rounded it off. And these are the numbers we got for what a developer is doing in a DevOps team. 50% of the time, keep that on one side. 18% of the time, she is going to the coffee machine, the toilet, having a chat, eating lunch. I don't know what they're doing, going to meetings, things like that, stand-ups. 32% of the time, they're writing new code and developing stuff that makes them happy. The stuff we want to do, we're making new stuff, we're improving on what we have, we're trying to get new products out there. Stuff. 50% of the time, you're dealing with issues, deployments, triages, problems. 50% of your time. Tell me it doesn't feel like the water's coming up around you, right? That's not what you signed up for. And this was amazing because this came along like about a month ago. This was off a Reddit thread. Somebody asked a very simple question. Hey, I'm looking at the open telemetry. I want to do some tracing in my organization. Any thoughts on that? You know how the internet is. There's always some really dry, sharp, on point response. And it was the very first comment. This guy's like, I don't collect spans and traces. I can't even get people to care. The developers are busy with a lot of other stuff. They don't have time to slow down and care about all this stuff. It's rough. And it's very true what he says here. There's a link in this. You can read that thread that's in the link. We just did some research at the company and just gave it out this last week. 500 developers and engineers were asked about their daily jobs and what they're doing and what cloud means to them. And there's a lot of stats in there and stuff, but I just grabbed two of them. This one it's pretty much what everybody feels, right? It's crazy how complex it's gotten, how fast we have to do stuff. There's no more breaks. Our code doesn't take 40 minutes to compile. You push the compile button, it's compiled, deployed, broke before you get out of your chair. Right? Do it wrong, it starts scaling up because it's trying to handle more load. So now you're costing more money. This next one breaks my heart. I never would have guessed this. Think about this. I know most of you work a little bit more than 40 hours a week, right? You love your job, you do. You don't love the job, maybe you don't, but if you're spending 10 hours or more on average messing around with triaging stuff, that means 25% of your time is doing crap you don't like. On top of that, it says 39% of these people said this is detrimental to my personal life. 22%, it makes me want to quit. I don't know what 22% of 500, but that's a lot.
And 40-hour work week is a bit optimistic.
Yeah, I agree. But I mean, whatever your work week looks like, I don't want to spend 10 hours doing that. And everybody thinks it's a really bad economy, but you know how they're always looking for help? Everybody's always looking for people. I don't care how many people we try to fire, there's always going to be someplace else that needs to have everyone hired. Why would you do this? Why would you do this to yourself? Like my colleague burned out 6 times. And you guys are young yet, 4 or 5 times, man. You're getting close. It's harsh, right? Really harsh. Take a look at that link. There's a lot more stuff in there. Like it's really depressing stuff, actually. But basically, what it's boiling down to is not that we're trying to depress the shit out of everybody. It's about there's ways to fix this, right? There's ways to fix this, and I'm still describing some of the problems here, but we'll get around to some of the fixes here towards the end. Some things you can look at. So FinOps is the crucial ops in this DevOps and all these other ops they're talking about. So this last fall, I saw, I think it was an IDC report. And it's in line with this question, what the cost of observability metrics data is. We've already kind of touched on how much stuff is being exploded into your world. Yeah, it's from an IDC cloud report in Europe here. That's a big number. I don't know if you guys look at the Gartners and IDCs and those kind of reports. It starts getting to be heavy duty pay attention time when it's around 40%, right? And then it starts saying, no, it's a trend, it's coming, it's going to happen, that kind of thing. This thing dropped out of the sky at 80%. I was like, whoa. So in 2022, at the end, they said by the end of 2023, so 1 year later, 80% of people, you know why? Exactly because if somebody does not own what's going on, things are just happening in the organization. Yes, the CIO owns it at the end of the day, but who is making these decisions and projects and architectural decisions? The architect didn't think about this one. Listen to this one. So imagine there's a marketplace and you're setting up your environments, you're building your stuff, you're working on a project, and there's a load balancer. You just look in and think, oh, load balancer, that's a very basic component. I'll just look in the marketplace, pick that one. Whatever this cloud provider is giving me, that's the one I'm going to use. Fantastic. Now security operations comes by and says, oh, okay, for monitoring and observability, we need to put some security tags on this. I see you giggling already, right? Here we go. So it turns out that these load balancers are in front of some applications. The applications are what they want to follow with those tags. But they got to put the tags behind the load balancers. The load balancers can take only a certain amount of these tags. I'm assuming 255. Just guessing. That's usually what the deal is. So what happens when you get more than that? Now you need another load balancer. And then another one. And now you're load balancing your load. What the hell are you doing? Right? They were able to fix some of that with some software updates and some bug fixes, but basically it's sprawled out into your infrastructure and nobody made this decision. Who owns that, right? So this FinOps, financial operations, is going to be the one that owns these kind of decisions, right? Can be held accountable for what you're pushing and what you're allowed to use and what that's kind of the idea. And I made a joke when the first time I did this, I was like, it was being recorded. And I said, who wants to be FinOps? I don't. So on LinkedIn, the guy popped up and he goes, I'm the head of the FinOps organization in the US. He goes, I want to talk to you. So we had a nice chat about it. I told him at the end, I still don't want to be a FinOps. But, you know, each his own. For everything is an opportunity, I guess. But you can imagine that, you know? That's got to be a crazy thing. Before we get into some of the stuff and fixes, I kind of wanted to jump on this one too. This is a freebie. This is still available, and it's really nice that Aaron touched on his 3 phases and how you're building these things and what you're doing in the cloud. This is a very generic question because people are looking at, okay, that step into the cloud or step into another cloud, right? It depends upon which one you're going to and why you're going. It really doesn't matter. There's like a little wish list here that came out of one of the customers we had. And I'm always stunned about this because I come from, anybody here do a lot of stuff with open source? CNCF, Linux, all that kind of stuff, right? What's the mentality in open source? This is an architect question. We all should ace this, right? What is the #1 question that's missing on this list? The first thing you should ask yourself when you do anything. I don't care whether you're picking a new coding language, a new tool, trying to make a change to your architecture, choosing a new platform. Architect answers. Anybody else can answer now. See if the SREs are smarter.
What problem are you solving?
Sorry?
What problem are you solving?
What problem are you solving? But that's what Aaron thinks. That was in his list, right? Nope. I think the #1 thing you want to ask yourself is, what's my exit strategy? That's open source, open standards, replaceable components, right? I don't care what cloud you go into today. Who knows what they're going to change the billing next week, next month? What use cases you implement that makes it unfeasible to be in that cloud and the billing costs of the billing cycles that they're doing. And one thing you always, if you take anything out of this story, please remember you want to have an exit strategy, okay? We talked a little bit about cloud data and about observability as data, and I gave you some depressing stuff. The upside is there's a lot of stuff coming down the pipeline in the 3rd generation observability tools, which I'm not going to promote my company, but I mean, that's what we're doing. And it's a rare thing that's happening. There's very few that are doing it. It's fully focused on cloud native environments, you know, in the cloud with all these kind of problems, these massive amounts of data. And a very simple example, when you ingest data using open source, Prometheus, things like that, there's a standard way of ingesting it, right? So you're looking at all these data, they call them DPPS, data points per second. So you have data points coming in, And you can look at those, and each one of those things is being ingested. And then it's going through and being used to draw a dashboard or whatever, and it's being persisted somewhere. Now, persistence is what costs money. So that was touched on a little bit by Aaron, that you can look at stuff and say, hey, I don't even need that data. Third generation tools pretty much come with a feature, which is really nice. And the SREs know about this, I'm assuming, that it'll look at the completely useless data points. It'll start with a list reversed from the stuff that's not used anywhere in your systems, which is why the questions at the front were a little bit important. Do you have an overview of all your platforms, all your clouds, all your environments? If you do, all this data is coming through somewhere, and you can look at it and say, oh, this is completely useless. You would be surprised how many times in pilots we find somebody, for example, ingesting 130,000 data points, drawing this dashboard because that's what they want to monitor on this specific area of their infrastructure. And it turns out, with a little bit of looking at these data points and what's being used, you can draw the same dashboard with 130 data points. What do you think your bill is going to look like with 130,000 versus 130? Are you guys running into this sometimes too? Or are you dreaming that you wish you had something like that? You know, it's utterly terrifying, the amount of data that's flowing around in this. And when you turn one of those features on and it flips around, and then you flip it the other way around, it shows you all the users that are using the data. So this data point is kind of crucial. You don't want to just drop it, right? Other things these tooling do that's rather interesting is, say our developers are having fun and they release something. And you divide them up in your observability tooling so that you see team A, B, and C. And you're going to find one of these developers releases something, and all of a sudden it spikes in cardinality. We say, you remember cardinality? That was a math thing we did in university, right? When I first got over here in observability, I was like, what are you guys doing talking about math stuff? And nobody understands what that is, right? I can hardly remember what we were doing with cardinality. But basically, it's an exponential explosion of data points. So you see a spike, and normally your credit card would go up in smoke, right? Or your budget for your team or whatever. You can have stuff in place that'll limit this and just stop it right there. Of course, that's a mistake, especially in the development environment. We don't want to smoke up our budgets. All right, so we've done the cloud data, the observability data, the FinOps is crucial, and I tried to leave you with some uplifting, non-depressing data points. Thanks for your time and attention. Thanks for letting me jump in here last minute. I really appreciate it, and I'm a little bit terrified of what questions I'm going to get. You guys are pretty sharp cookies, I saw in the first session. So thank you very much.
Got about a minute, so I'm gonna take over the slideshare again, the speech here, and any questions for Eric, or of course just raise your hand in the room. Oh, one back, hold on, come around.
The point you made about exit strategy, I found, sorry.
Yeah.
How you doing?
Sorry, my face.
Yeah, it's okay. The point you made about exit strategy particularly interested me. I don't do anywhere near as much as I want to, but I'm trying more and more to do more open source oriented work. I'm also a consultant, and I see so often it's always been not a thing that everyone knows that it's difficult to move from cloud to cloud. But when you look at it as an exit strategy, it becomes more obvious that it almost seems somewhat deliberate from the cloud providers, and I get that, right? I'm not having a go at any cloud providers, as anyone in the room who works for one. But what do you see in terms of almost a reluctance from the cloud provider to adopt open technologies and open standards that would help people alleviate that pressure and ease their exit strategy? And I know it's case by case basis. What would you recommend to try and avoid any of the major pitfalls that you can fall into that will screw your exit strategy and move you towards proprietary or closed source options inside of a half in, half out / proprietary system?
Yep. I gotta wait for this. See microphones. It's very easy, right? Because you've thought of an exit strategy. What's that mean? I'm not going to commit to anything that's proprietary. That's your first thing. A cloud platform is a platform. What you put on it is on you. You're just gonna run willy-nilly and push all the things that are on the platform in the marketplace?
But then you're like turning off like probably like 80% of.
I'm not even turning anything off, you just haven't turned it on.
Yeah. That's what I mean though. Like you're closing off 80% of those doors inside that cloud platform.
Well, this is the message from places like Red Hat and IBM now. The OpenShift container platform is a standards-based platform, they're saying, right? Vanilla Kubernetes, something you can trust. It's not going to change under your feet. You're not using, stuff straight out of the open source projects. And it also migrates across all the clouds, right? If you're running on top of something like that, all the stuff you've done with your apps, your devs, your whatever, and that sounds like I'm selling for them, but I mean, it's a very clear example of what I'm talking about. If you put a container platform on there and don't just jump into like Lambda.
The problem, to give one really like bad example is identity and access management. That for me more and more seems to be, sorry.
Yeah, but that's traditional. You can't get away with it from it.
Well, yeah, one thing that is particularly bad, because I think someone said like you can't get away from it, is identity and access management. Obviously, people might be aware there are open standards. There's an open standard called Spiffy. I'm learning more and more about this, but if they shifted to something open, the world would be a better place. But unfortunately, there are some parts of the cloud that it's unavoidable. It's almost like the Triffids, they weave their leaves in and it's impossible to get out. But
So change it.
I'm trying.
Change it.
I'd like to do that.
That's the part about open source that's nice. That's the fun about open source. And what's nice about this, you can change it. A really good example right now, I just joined a work group in CNCF that's trying to put together a common query language, right, within Prometheus. There's a bunch of implementations. That's a problem. There's a sort of I call it the unofficial standard, right? When you ingest with Prometheus, then you're ingesting with an open source standard. If you use PromQL, then you're now using an open source standard. It's not an official standard, which is what we'd like to make something like that. So everybody goes out there and makes their own little bit different thing, which makes it really hard to take your queries, your alerts, and all that kind of stuff in your observability platforms and just migrate them. People write tools to do that to get certain ones over, but not a lot of fun, right? And architects and all of us would be much happier if we could all write our engines against standards, right? Great example is Docker. They went out there and were kicking the crap out of everything until people decided, hey, let's step back and do open container initiative. A centralized standards-based Linux Foundation thing, right? And now everybody can write their own engines. You have Podman, you have Docker, sort of. You have, there's all kinds of stuff out there you can use and switch as you see fit. It's up to you. I'm getting the evil eye from you, Emma.
And for observability, currently Open Metrics is the leading one. Open Metrics.
Okay.
Open
I'm going to
telemetry,
suggest that we go to break and you grab Eric and chat with him more.
Okay, I'm leaving. Bye.
Not of course, please, Eric. Okay, we're going to take a 10-minute break now. Please go out, grab any drinks and pieces of stuff. And then we'll be back at 8 o'clock for our third talk of the evening.
Talk again, I forgot.
An arm full of clusters.
Arms.
You say I work arms, so you should stay.
Hello, I'm Brian. You won't know me. You might know my friend Ashley Ward from Palo Alto. Well, was for a while.
That's why
To exclusive networks these days. I've attended a few actually. That's the first one. To be here in person. I'm at VMware Tanzu these days. So it's all very similar for us. You might be interested in some sponsorship and pops as well. Just to email you with a separate chat type.
Yes, thank you. Business card.
No, I don't. Far too modern.
I know I don't have this. I don't know why.
I think I meant to print them off or get them printed, but it's just about.
Exactly. You want to drop your email in there?
Yeah, sure.
And then just I'll follow up with that.
It was hilarious.
Yeah, sure.
Thank you so much.
No worries, sweetie. I really appreciate you coming. Sorry, after coming to this virtually.
So I'm based up in Edinburgh, so it's more slight to everything else. I was working for Sky TV before, so big and now VMware is a bit more travel, so down for other things. So it's like, right. So I'm going to try and organise things here and there at the right time.
Yeah, that will be.
But not anyway, so just a quick thank you for setting up the event. Very much work goes into it.
I enjoy running, but yeah, it's a bunch of work. But again, like I get a lot of joy out of it myself. I really enjoy getting together kind of actual events. It helps me stay in touch with what's happening. I enjoy it.
Congratulations on your role as well. All very exciting. The chapter ones.
Changes, everything changes.
Right, thank you so much.
Thank you. Sadly, hi, good to meet you.
I was just wondering,
only because the name.
so we
After Christmas, I guess. I'm still. I came back.
and I would like it. And sounds like
I'm not there yet. Yeah.
But I actually, if I mess with my date, I'm gonna go and nice stuff. I don't know how. Yeah, how fast we actually.
Actually, next question. I'd ask all people. What's the capacity? Okay. So I try and stay upfront when I go in there because people get confused around the pod. So because we suggest
Oh no way!
All right.
so literally
That's so cool.
I had to stay there.
Oh my god!
No, maybe around. We've been here for like about 8 months.
Make sure I'm not going into bad
And
area.
then moving to different. But I always try and keep any venues in London.
Yeah.
I keep a list of it so that I can work out next time that I'm looking around.
Yeah, actually, I don't know if you're in contact with I'm trying to like get into Primark. Yeah, so I'm like happy if you get me in touch with anyone.
Send me an email.
I can.
Email's better. Yeah, if I know of anyone else. Yes, I'm on Twitter.
Yeah, I messaged you on Twitter for that.
Oh, okay, perfect.
Thank you.
Thank you very much. Hey, how's it going? Yes. Oh my gosh, you're here, like in person. Like, amazing. So, that's right. Yeah, the timing of everything. I know I started and I never made it, so I'm really sorry about that.
Message you on WhatsApp for the
Perfect. Yeah.
I wanted to ask
So there's a web page which gives all the details about how much it costs and how you can pay for it. If you go to cloudnativelun.com and sponsor it. Yeah, so the information's there, and then you already stuff. So when I would share that page with your and handles that. If they want to come and speak to me.
Josh was with me, so he was like, you should.
Oh, nice. I appreciate it. Thank you. Thank you. Yeah. Well, I really appreciate all the stuff around SIBO. I'm excited for it. I know in my head, like, Christmas was a big, I managed to get you that. But yeah, but I'll be there in Tampa. Thank you. Thank you.
Yeah, but is it easy to say that
I know. I had two people say they like
so I'm looking at because we are obviously out of the
maybe I'll get him to
in the first year of the honors list, there's a guy who was in that, you know.
I run a company.
Yes, you're
I've got to see confident people. I don't know. See, still half.
There's always stuff.
I find it funny. He asked me. He asked that. I'm surprised he doesn't ask. How is it?
Especially with the new
You were like,
I stopped stroking. Okay, sorry. It is, it really is. Yeah, we do.
And somebody else to talk about. No.
Any of the guys from Paris?
Like after my conference. Yeah.
Let me know which ones you want to buy for you. It's happened to me in other meetings. For me, it's
He's insane. I'm here watching the whole thing.
No, you weren't. No, you weren't.
Just make it broken for you, so it's typical. Most companies have tried it. Oh, the drum. Microsoft just shuts off.
All right, come on in, please. We're going to have our third talk of the evening, which is an armful of clusters. So, Carlos, I'm going to hand it over to you. Share your screen and take over. Cool, I can see it.
Nice.
Yes, I hear you. All right, it's all yours.
Thank you very much. I'm sorry, I cannot be there because it was in so short notice. I knew I was going to give this talk 2 days ago, so it was impossible to go there to London. I'm in Spain, in Zaragoza. But anyway, online, it's fine. So we can have this talk. I know it's late. You want to go to have some beers. So I'm going to do it like light and quick and fun, and so we can enjoy and then have some beers. First of all, let me introduce a little bit myself. I'm a communications engineer. I have 15 years of experience in IT. I've worked of everything, admin, IoT, DevOps, and lately I've been specializing in Kubernetes and cloud native. I've been working especially on observability. But now I work a little bit on everything, and I am an open source enthusiast. I like to use everything in open source as much as I can. I use Linux, I use everything. So come on, open source. And this is my first computer when I was 4 years old. My brother had this for as a present. He was 9, so we had together a lot of fun with it. And a little bit of me, I like video games, Star Wars, films, movies, books, sports, music, and everything related to technology. And I have 3 special helpers that help me to debug Kubernetes when it's not working properly. The agenda is like, first of all, let me introduce a little bit about ARM processors. What are the advantages they provide? And then let's see how to run Kubernetes in ARM processor, in ARM machines. And then how to run these applications or how to transform these applications so they can run in these ARM clusters. And then some time for questions and answers, I hope. Some context. In 1985, I don't know if many of you were here, maybe. Some stuff that happened that year. Some are good, some are bad. I let you decide which is bad and good. But the main one that I want to focus is Acon creates the first ARM processor. It was not a processor per se. It was like a coprocessor for another processor, but it was like the first ARM architecture that was created. And from there, there was a lot of versions and evolutions. You can see here a lot of machines. This is the first one, the V1. And then you can see different machines that had this processor, like the super famous Raspberry Pi, the first iPhone, and I would say any Android or iPhone that you have right now in your pocket, it's ARM processor. And now, recently, they were already popular in the mobile world, but now they are popular too in desktop and server world, which is something that it's increasing a lot, the usage in data centers and all this, because of the things that I will tell late about the advantages that it provides. The main features are that it's a RISC architecture, and this architecture is more efficient in power. In addition, they are multi-purpose processors. Most of the processors right now are multi-purpose, but they have different cores that you can optimize for different tasks, depending on if you want to optimize for efficiency, if you want to optimize for performance, or for more computing power. So the performance right now is comparable to the x86 architecture, and sometimes even better. That depending on the benchmark you see and who is providing them. But we will say that they are comparable. And one of the things that made the ARM processor really popular was that you can license some the cores and make your own custom CPU. For example, Apple in the iPhone or in the MacBooks now created, based on the ARM cores, a proprietary CPU that they use, so they can create their own custom socks and make the processor very well fit for the application they need. For example, iPhone, they need a lot of performance, power efficiency, and some functions that allow the phone to work and the battery to last a lot and things like that. So main advantages in a glance: power efficiency, and they are cheaper. They have a lower cost because the architecture is more simple. Let's see, Kubernetes in ARM. This is the interesting part. Okay, so we have here a very famous people saying, Kubernetes is super easy. You can do it in 4 Raspberry Pis, and it's super easy. Okay, so you can do Raspberry Pi cluster. You take 4 Raspberry Pi, which is like, I don't know, €100 or $100, and install micro KAS, K3S, or one of these solutions. That's a very simplified version of Kubernetes. And then you have Kubernetes in ARM. Okay, so I'm fine. I'm done. Thank you for listening. If you have any question, okay, I'm leaving. Right? Wait. No. Wait. K3S and micro KAS are solutions that are really good for testing and for tinkering and for home doing some stuff. But these are not real Kubernetes clusters, at least my point of view, as I see them. So when you see a Kubernetes cluster, sometimes you see this diagram, which is from the CNCF page, from the official Kubernetes page. But I see this. I see a lot of applications that I need in order to properly run applications. I need security, so I need Falco, Kyberno, or any other application that provides security, 3V or wherever. I need Prometheus for monitoring. I need logs. I need Flags for GitOps. I need Nginx Ingress in order to control all the networking, or Cilium, or any other service mesh. You need Kong for Ingress, Crossplane to be able to create resources, Istio, whatever. There are a lot of applications that come from with Kubernetes, and that are most of the times required in order to have a production-proof cluster, like things that you can run with confidence that everything will work, with enough functionality that you can provide a platform with them. So in order to do this kind of more complex strategy, there are different strategies that you can follow in order to create this cluster. First of all, you need to think about your own applications and how they work and the applications that you need along them in order to make them work. So first of all, the first strategy is, okay, I want ARM cluster, but I don't want to tinker a lot with Kubernetes. So I just let the control plane alone with x86 machines, with ordinary EC2 machines, and then I create nodes working on ARM that will run applications there. All the nodes that run the applications will be ARM, and these have some advantages, some disadvantages, and this could be recommended in some cases. So let's see. The cool things are all the control plane nodes are x86. This means that you don't need to change the control plane. This is not totally true because you have to change some components that work in the nodes, like, you know, kubeproxy and other things, kubelet, but it's mostly true. And all the worker nodes are equal, so it's easier to schedule things. You don't need to think about, oh, I need to schedule different things in different nodes. But there are some issues that could arise. For example, what happens with daemon sets that need to run in all the nodes, like something like Prometheus exporters or node exporter that need to run in all the nodes in order to have these metrics. Then these applications need to be ready to work on both architectures, x86 and ARM. And then you need ARM images for everything that runs in the worker nodes. Everything that is running in that cluster, any application needs to work in ARM. This provides a little bit less efficiency than if you would run your full cluster in ARM processors. But it's kind of a equilibrium, a balance between efficiency and being able to do it easily. So when it's recommended to use this strategy, if all the apps I'm running have ARM version, this can be a good strategy to do it quickly. And this allows you to you don't need to modify a lot the bootstrap mechanisms that you use to create these clusters. So it's more or less easy to do. So it's like a easy half a step in order to introduce you in the ARM world without having to change a lot of things. Then you go all in and you have everything in ARM. This is very good because you have this super power efficiency gain, okay? You are using cheaper machines, so you are saving money. And every node in the cluster it's equal, so it's easy to manage and so on. But now you need ARM's images for everything. Everything that runs in that cluster needs to be able to run in ARM. And then you need to build and maintain all these ARM images that maybe, for example, most of the applications have, but I find this application that doesn't have an image or an official image in ARM. I have to create it and maintain it. And Kubernetes control plane in ARM, it's supposed to be working, but it's not as tested and proof as the x86 version, which is using everywhere. So you might have some strange behavior, some bugs, some efficiency problems there. So this is the case when you want to go all in and you want to say, no, I want to save a lot of money. I want to save more power. So I'm more, green these days. Being green is important. So I want it all. And I am pretty confident that all my applications can run in ARM, and I could be fine. So now I am changing all the creation process of my clusters mostly. So if this is easy, maybe this is a good strategy. But we need to be aware that this requires a lot of changes. And now we have some middle ground between the two of the past strategies, which is I have nodes that are x86, I have nodes that are ARM. So we can decide if control plane it's ARM or x86, depending on how how risky do we want to go, or if we want to save more money or be more eco-friendly. And then we can run several apps that don't have an ARM version, which is super fine for example, if I need a specific networking or security application that doesn't have any ARM version, I could potentially run it in this x86 nodes and then use the ARM nodes for most of the workloads. The issue that we have with this is that when you have daemon sets that need to run in all the nodes, you will have x86 and ARM nodes, which would make it more complex to manage. We need multi-arc images, and the scheduling of all the workloads will be much more complicated. We need to manage the applications, which applications go to which node, which means node affinity, which means tension toleration, which means all these mechanisms that Kubernetes offers to decide where to schedule the workloads, which is not super complex or super difficult, but it adds a new level of complexity, which in case of problems would be more difficult to debug or to fix. And then, depending on the number of nodes that you have, x86 and ARM, you will have less power efficiency, you will save less money. So this is fine when you need to use x86 version for some applications, but you want ARM very badly because it's super important to save money, it's super important to save the environment. So I want it. And maybe in the future, I'm being prepared. So when the applications that I run in x86 have an ARM version, I can just switch and be ready to have a fully ARM cluster. Oops, sorry for the translation. I made these slides originally in Spanish and I translate them, but it seems I skipped some. Sorry. So now there's an important thing when you are creating applications, that it's how can I change my development process and all the things that I need to do from code to application running in the Kubernetes cluster to work on ARM. So I divided this in three spaces, more or less general. That is the compilation. I need to compile the application to run in ARM. This is pretty straightforward for most of the languages, but I don't know, maybe you are developing something in COBOL still, and I don't know, this might be complex for some people. CI/CD pipelines, which is from code to something that you can deploy in the cluster, and the image registry, which is where you are storing all these images, and that can add some layers of complexity when you are using multi-arch or different images with different architectures. So compiling, is it difficult? Depends on your language. It could be pretty straightforward with some languages like this, C, for example, or Java, that they have tool chains that allow you to compile in ARM more or less easily. All the things that they used to run in phones, tablets, or things like that, you have a very good chance that they can run in ARM easily. You will have like virtual machines or interpreters that are running ARM. So For modern languages, it's probably not really complicated. The only thing is that if you are running in ARM and x86 environments, you will need to maintain both compilation, both creation. You have to test both pipelines, so you probably need to work a little bit more. Regarding CI/CD pipelines, you need to be ready to build your images twice, probably. You need to be ready to cross-compile everything and build images for ARM processor, and probably multi-arc images. The problem with multi-arc images is that they probably are bigger, not necessarily twice, because you can reuse most of the layers and probably increase the size, but not by much. But it's something you have to have in mind in order to size the storage of your registry accordingly. You have Docker buildx, which is a tool that allows you to create multi-arc images more or less easily. So there are tools at hand that allow you to do this, not easily, I would say easily, yeah. Then you need to test everything, because we all test everything we do, right? Right. So you need to create ARM environments in order to test these two, not only the usual testing machines that you have, but you need to create clusters or machines in ARM to run this test for these ARM binaries or images or whatever. And usually you will need to maintain both environments, so you will need to create tests in ARM, in x86, and maintain both of the environments, which can be costly too. And then deploy. Can you deploy in ARM machines? I mean, sometimes it needs to change manifest in order to specify that the image is ARM architecture. And you might need to change things if you are doing scheduling, because you have different nodes. You might need to do like taints and toleration, node affinity or anti-affinity, these things in your manifest that could need some changes and that could need some maintenance, of course. Is it complex? Probably not a lot, but it's something that you should have an eye on, and that could probably add some cost. So if you say, okay, I want to use ARM processors in order to save money, have in mind that you might add some cost in all the development and CI/CD process. And then the registry. Some time ago, it was fairly easy to use a registry, and then this registry doesn't support multi-arc images, and then this doesn't work. It is ignoring the manifest, the architecture tag, and it gives me always the x86 image or things like that. So all the modern versions of the common registries like K, Harbor, and Docker registry support multi-arc, but you need to be very sure of the version that you are using. You need to be sure that everything works in your registry. So it's something else that you have to have in mind in order to support these ARM clusters. So main takeaways that I have from ARM cluster is that we can save money and we can save power, which means we are being more eco-friendly, and that's a good thing. Kubernetes in ARM is not easy if you are going to a production grade quality. I mean, you need to run a lot of applications, you need to run a lot of things along with Kubernetes. So it's not installing K3s and then voila. It's more complex. You need to test a lot of things. You need to test that everything works together. So it's not an easy thing, and it requires a lot of planning and a lot of effort. And checking all the software that we use or produce is not trivial. Probably our software is easy to do, or at least we have control over it, but maybe we are using a third-party application which we don't control, and we don't know if it will work or not, or when it will work. Maybe they say, no, we will eventually do it. but we don't know when. Okay, so this is something that you have to have in mind too. And you need to add the cost of maintaining and creating all these duplicated pipelines, tests, and everything that allow you to deploy this ARM and x86 application. So now, if you have any questions, thank you very much. I'm sorry I cannot be there for the beers, but you can save me one for when I go to London. So thank you very much. And questions? Now.
Thank you so much, Carlos. I'm going to once again pop up the questions. So if you have, again, that link from earlier, you can post questions live here or in the room if you want to raise your hands. I found this very interesting, by the way, but I'm biased because I work for ARM. Also, one thing I learned that ARM should be capital A, lowercase rn. I did not know this until I got.
Sorry.
It's okay. I only learned this after I joined.
I will change it for the next time.
Okay, any questions? Yeah.
Have you got any registry to that which consists all the images run vanilla Kubernetes for running kube controller, scheduler, and etc. from the vanilla mode, not just like K3s, because the K3s compile all the things together and it launch on a single process, not just like vanilla.
All the Kubernetes control plane components have ARM images with different degree of polishment of them. So some of them work very well and some of them work if you're lucky. So that's more or less the adventure, like trying everything, because sometimes if you have like an average usage of a cluster, you never use some of the features of some components, but when you need them, have this been tested? Has this been proof a lot in production? So that's the main question. Is like you might have bugs that nobody knows about it because nobody tested in ARM processors. So that's the question. At least they work in ARM. The degree of the polishment is.
Did you test the vanilla Kubernetes on Raspberry Pi?
Sorry?
Did you use and test vanilla Kubernetes on Raspberry Pi? Not with K3s or MicroKS?
I haven't.
Okay.
Can you give us any live production examples of the multi-architecture installation you describe? Any use cases and what the benefits are, business benefits in particular?
Can you repeat? I couldn't hear it very well.
Can you give us any live production example cases where you have a multi-architecture installation and what those business benefits are? Anecdotal or otherwise?
I haven't seen this kind of cluster in production anywhere. Just development, tries, test, but you need to be very brave in order to push forward to production these kind of things. So I've seen proofs of concept, development stuff, but nothing in production yet. Everyone that goes in production, it's very polished and goes full ARM or not at all.
Yeah.
You want to take some of these questions?
Multi-arch is very tricky.
Yeah, I figured.
So do you think there will be a trend towards ARM because of climate change? Yes, not only because of climate change, but I think one of the main trends that will arise this year in cloud native will be cost, reducing cloud cost. And ARM is much cheaper than x86 in current cloud providers. So that will be probably we will see people moving for the cost, but then having the climate change or CO2 reduction as a marketing stuff. But it's true, and I think it will help. Where do the consumer market fit in the world of ARM? I think it makes sense in many things, but you have it in your pocket right now in like tablets, mobile phones, and so on. So I think it's pretty clear that it's going to be widespread in the consumer things. I have here a MacBook Pro, which is ARM processor, so everyone will have ARM in one flavor or another, so it will be everywhere. And if efficiency is in the foreground, shouldn't you review the languages you use first? An example, using Golang instead of Python? Yes. That's why I see this like a multi-facet thing that you need to look everywhere. You need to, of course, use the language that is more efficient. That's very important. And it's probably, depending on your application, you will have more room for improvement, changing your code only, even not changing the language, than changing to ARM. But then we will get to a point where everything will be so polished, and if you are using third-party applications, you don't have the ability to change that. So if a fair percentage of the applications that you are running are not yours, like I'm using Falco, I'm using Kyberno, I'm using Cilium, I cannot change that. I cannot say, oh, can you please change and use Golang or update to the new version of Python that is so much better in the performance. So you don't have the chance to do that many times, and you need to go to a different strategy. Like, what if I run it in a cheaper machine or in a less power hungry machine? So that depends on your workload, depends on your application, depends on a lot of things. And of course, you need to look all of them.
Cool, we're just about over time. So round of applause, please, for Carlos.
Thank you very much.
And I'm going to take 1 minute to add in my professional capacity from ARM. I'm the Senior Director of Ecosystem, and it is my aspiration to make ARM much easier to adopt over the next couple of years. So languages, packages, these components in the control plane, like if there are things out there that we could make it easier to provide ARM images for those, if you ever try this and you're running into something that doesn't exist, then I want to know about it because I can make it happen. Okay, that's it. Thank you so much, Carlos. Really, really appreciate it. And thank you to everyone for coming here this evening. As I said, we are going to be in a new home from February, so I'll see you in the Just Eat headquarters in Holborn. I want to say a special thank you to Harriet, who has been the most amazing host from the esynergy side, so please a round of applause for her. Chili the dog is the most important one.
So she's been trending on Twitter with you, not someone to put a post up.
It's quite amazing. All right, we're going to go to the Tank and Paddle for more beers and drinks and catch up and chat after this. Thank you so much. See you again soon.